Change in the order of integration in double integral from 0 to 1 x squared to 2 minus x xy dy dx. So the region of this integration is bounded by the lines. Now here if you look that you are having the limits for y as x square and 2 minus x. So the lines are given to be as y is equal to x square and y is equal to 2 minus x. And the limits for x are given as 0 to 1. So the lines is x equal to 0 and x is equal to 1. So let's draw the region. Now x is equal to 0 is this line. This is your x equal to 0. And x is equal to 1, which means this line x is equal to 1. This is x is equal to 1. And now drawing the graph for the y equal to 2 minus x. How to draw this y is equal to 2 minus x? Just put first, if x is equal to 0, you get y is equal to 2. So if x is equal to 0, I am getting y equal to 2. So this is the point. And if y equal to 0, I get x is equal to 2. So the other point is this. I get 2 as y equal to 0. So making the line as joining these 2 points. So this is the line for y is equal to 2 minus x. Right? Okay, so the last one is y equal to x square. So this is the parabola. This one. Right? If you notice that it is the point of intersection. Alright, so this point of intersection is 1 and 1. So now to draw, I have get this region, right? And because this is the point of intersection, let me divide this region. This is your region, this complete region, right? Now because I'm having the point of intersection as 1, 1, so let me divide this region into 2 parts. Let this be your 1. So now because the limits of x are constants in the given double integral, so whenever the limits of x are constants, we have to draw the strip parallel to y-axis. Or in the other way, you can also notice that the limits for y is in variable. So the limits for y is in variable, so we have to draw the strip parallel to y-axis. So I remember as that if the limits for x are constant, so I will draw the strip parallel to y-axis. If the limits for y are constant, so I will draw the strip parallel to x-axis. Now in this double integral, the limits of x are constants, so I am drawing the strip parallel to y-axis. So this is the strip. For the given double integral, right? Now because I have to change the order of integration, so this strip will also be changed to horizontal strip now because I have to change the order of integration. So to change the order of integration, which means I need to first integrate with respect to x and then integrate with respect to y. Now, to change the order of integration, this horizontal strip will be now vertical strip. I'm changing the color of the pen for this. So this is your strip now. this horizontal strip means one more strip for the above region, for this region 1, and this is your region 2. So 2 horizontal strips for region 1 and region 2. So let me also name the region first. This is O. Let me name this point as A and this point as, suppose, M, and this point B. So this is A, B, M, O. Right? Alright. Now to find out the limits for x first. First of all, the region is divided into 2 parts. So I have to split the integral into 2 parts. So I have taken this, the original integral, and after changing the order of integration, so I must be having this the original integration is this for dy dx. Now after the changing the order of integration, I get dx dy, right? And now splitting this integral into 2 regions, right, into 2 parts. The first region is OAM, right? So for OAM, what is the limits for x? For OAM, for OAM, the limits for x. Now because x is varying, the limits for x starts from O. Here the value of x is, here the value of x is 0. So limits will be start from 0 and reaching, here the value of x is, what kind of the curve is this? This is your y equal to x square. So here the value of x is, because according to this horizontal strip, the value of x starts from 0 and reaching this curve. Here the value of x is square root of y. So writing here square root of y. And now putting the limits for y, which is constants. Now y start for this region OAM, the limits of y are from 0 to 1, right? From 0 to this point 1. Similarly, for the second region, this horizontal strip means x is varying. So first writing the limits for x is starting from 0, here x is 0 and reaching this line. This line is y equal to 2 minus x. So the lower limit is 0 and here the value of x is 2 minus y. So writing here 2 minus y. And the limits for y, because the region is now BMA. So y starts from here. For this region, here the limit of y is 1. It is constant, right? 1 and final limit is 2. The lower limit and the upper limit. So y starts from 1 to 2. This point and this point. It is clear? Let me explain again. Okay. For the first region, the limits for x are, because this horizontal strip means x is varying. So the limits from x are started from 0 and reaching this parabola. So the value of x is from 0 to square root of y. And the limits for y is for this region OAM. The minimum limit for y is 0 and the maximum is 1, right, for this region. So you can also check the y-axis only. Don't confuse with the regions. Just check the y-axis. The region stops here and here I'm having the value of y as 1 starting from 0. So for region 2, the value is from 0 to 1. I'm very sorry, I have written first the integral for second region and then added with the first. So okay, let me change this. Let this be your region 1 and this is the line of intersection. Let this be region 1 and this be 2. So for region 1, I have explained the limits. For region 2, okay, for region 2, this horizontal purple colored strip means x is varying and the limit starts from here x is 0 and it touches the line this y equal to 2 minus x, and here for y equal to 2 minus x, I get the value of x as 2 minus y. So the limits of x are from 0 to 2 minus y. And the limits for y, the region is BMA. So y starts from 1, just see the axis of y. Y starts from 1 and reaching 2. Right? Here ends up the region. So the limits of y from 1 to 2. Is it okay? For the first region, the limits of y are from 0 to 1. For the second region, the limits of y are from 1 to 2. Is it okay now? Okay, thank you. So now solving the integrals. 0 to 1. Now integrating first with respect to x, taking y as constant. So this is x square by 2 from 0 to root of y, and this is dy. Plus integrating xy with respect to x, taking y as constant. So this is x square by 2 and the limits are from 0 to 2 minus y. This is dy. So this is equal to 0 to 1 integral y and putting the limits. So x square, putting the upper limit square root of y, it becomes y over 2 minus putting 0, I get 0. And now putting the value as 2 minus y here, it is whole square over 2 and then 0, it will give 0. So this is equal to, this is now half can be taken outside. This becomes y square and integration for y square is y cube over 3 from 0 to 1 plus taking 1 by 2 outside and multiplying these two from 1 to 2. Just multiply these two first. I'm writing y, opening this. This is 4 plus y square minus 4y dy. And if I multiply this, I get 4y plus y cube minus 4y square. So I'm just multiplying them. 4y minus 4y square plus y cube. So this is equal to 1 over 6 and this will give you 1 only plus 1 by 2 integration 4y y square over 2 minus 4. This will be y cube over 3 plus y4 over 4, putting the limits from 1 to 2. So this is equal to 1 over 6 plus 1 over 2. When you solve this, you will be getting, just putting 2 over here, you will get, this will be cancelled out 2, this will become 8. And then putting 2 again, it will become 4 into 8 over 3, that is negative 32 over 3. And after that you get 2 to the power 4 over 4, which will give you 4. Minus, now putting 1, so you get, this is 2 minus, this will give you 4 by 3 and it becomes plus, but I have taken the bracket so it is minus only. And then this will give you 1 over 4 plus 1 over 4. So this is equal to 1 over 6. When you solve this, if you are not simplifying this, I'm just writing the answer, you will get this is 32. Don't confuse with 3 square. Thank you so much. So when you simplify this, you will get your answer as 3 over 8. Alright, thank you. God bless.